This is Engage New York, Module 4, Lesson 2. Read the objective with me as I read it out loud. I can interpret a fraction as division. And that's something that we've been talking about for quite some time, is how division problems are fractions are division, fractions are decimals, and how all of those things go together, right? All right, so we're going to actually start with the application problem. So the application problem says, the line plot shows the number of miles run by Nolan in his PE class last month, which is rounded to the nearest quarter mile. So the PE class, these are the sets of data. This is how many people ran. And this is, so the number of miles ran by Nolan in his PE class last month. So how many times did he run 1/4, 1/2, 3/4, and 1 full mile? So your 3 questions, based on looking at the data only, if Nolan ran once a day, how many days did he run? How many days total did he run? How many miles did Nolan run altogether last month? So all together, what operation do we use when we're talking about all together? All right, now look at the circled data, this one right here, that data point. The actual distance run that day was at least blank of a mile and less than blank of a mile. You're going to fill that in. Then, so do you know what? I'm going to give you 5 minutes to work on this problem, and then we're going to come back and check. Okay, so if Nolan ran once a day, how many days did he run? That's right, 10 days. How many miles did Nolan run altogether? So once I add this up, here's 4 1/4, 2 1/2. Here's 1, and I added up what I had left over, 1/2, 3/4 plus 3/4 gives me 8/4, and I end up with 2. Add those up, and you end up with 5 miles. Now, look at the circled data point, right? This circled data point right here. So the actual distance ran that day was at least how much? 3/4 of a mile and less than 1 mile. All right, good job, you guys. All right, so here's our fluency. We're going to complete these sections and then come back to correct. All right, so 50 times 2 is $1 or 100, right? A 50-cent coin and a 50-cent coin makes $1. 25 times 4 is 100. 4 times 25 is 100. 20 times 5 is 100. 25 times 4 is 100. 50 times 2 is 100. 5 times 20 is 100. 10 times 10 is 100. 4 times 25 is 100. Then comparing the fractions, what you're writing down what section of the tape diagram is shaded in. 1/2 is shaded in. 3/4 is shaded in. 6/8 is shaded in, but 6/8 can be simplified to 3/4. 9/12 can be simplified to 3/4 again. And then when you look and you compare these tape diagrams, notice that they all take up the same amount of space. They're all 3/4. Then what do you notice about these fractions? 1/2 is greater than 3/8. 1/2 is smaller than 5/8. 3/4 is smaller than 7/8. And so notice how I multiplied in order to create like units so that you could compare them more easily. 1/2 is smaller than 3/4, and 3/4 is equal to 3/4. Then we have decomposed fractions. So here's our number bond, 1/5, 1/5, 1/5. So 1/5 plus 1/5 plus 1/5 and 3 times 1/5. 1/3 and 1/3. 1/3 plus 1/3. 2 times 1/3. 1/10 plus 1/10 plus 1/10. 3 times 1/10. 1/8, 1/8, 1/8, 1/8, 1/8. You could also do like 2/8 plus 3/8, but then if you did that, you wouldn't be able to say 5 times 1/8. Then divide with the remainders. Remember, the second number is the one that actually it becomes the divisor. So 2 divide 8 is 4. 5 divide 25 is 5. 0 remainder. 5 goes into 27. 5 remainder 2. 2 goes into 9. 4 remainder 1. 3 goes into 9. 3. 6 goes into 12. 2. 3 goes into 10. 3 remainder 1. 6 goes into 11. 1 remainder 5. And then 4 goes into 16. 4 remainder 0. Yes? All right, that'll do it for fluency. Come on back for concept development.